So let's proceed. Have you learned these two all three formulas, set of formulas?
Yes, sir.
Yeah. So as we were discussing earlier, we wrote the quadratic equation in this format, like after ax square plus bx plus c. We actually did divided the whole equation by a. So it was actually this. And now, as we also know that alpha and beta are the solution of this equation, so we can also similarly write it in this format. X minus beta, and this is equal to the same quadratic equation. This is equal to 0, and which is also equal to, maybe right. This is also equal to this. So we will multiply a on both sides. So we'll get this equation. Clear?
Yes, sir.
Yeah. So let's move forward to the next example as it is given. So now first tell me, what is the sum of all interior angles in a triangle?
180 degree.
Good. Do you know about this formula?
Yes, sir.
What is it?
Is it? No, no. No, sir. No. Polygon, I don't know, sir.
This polygon is what? What is polygon?
Which is a closed figure.
Ah, close to define. Okay, so you can like remember this. These are additionals. Now coming to this question, given that there is a triangle PQR, R is a pi by 2. Pi by 2 is 90 degrees. So it is a right angle triangle. So for visualization, let's draw it like this. R is pi by 2. This is P and Q. And it is given that 10 P by 2 and 10 of Q by 2 are the roots of the given equation. Okay. So there is a given equation and its root are 10 P by 2, 10 Q by 2, Q by 2. Now we have to find out the relation between the coefficients of this given quadratic equation. Okay, so let's try to first see that what is given in the question, because there's like solution is driven mostly out of the question only. So it is given that R is a 90-degree angle. So we know P plus Q plus R is what? 180 degrees. And R is what? 90 degrees. So P and Q must be,
Um,
this is 90-degree angle.
90, sir. 90.
Yes. So P and Q, the sum of P and Q angles must be 90 degrees. But we are discussing about the tangent of the half angle. So let's try to divide this equation on both sides. 90 by 2 is 45 degrees. So now we are aware about one formula. Also, let's see, because when we are discussing about quadratic equation, why we are doing so? Because we are discussing about the quadratic equation. Now we have to find out the relation between the coefficients. But we know also one more thing, because as the roots are given, we know the relation between roots and the coefficients. So like if we add these two roots, minus of b by a, correct? We will subtract these two roots. Sorry, if we will multiply these two roots, so what will be its relation and coefficient. What is the product of fruits?
Product of fruits.
What is alpha into beta?
C by A.
Yes. And these are roots only, na? Alpha, beta are what? Roots. So simply when we will multiply two roots, it will be C by A. Here C by A. So now we know, as this looks like that we can make out from these two, like these two given terms, we can make out that there is a formula of tangent P by 2 plus Q by 2. Then we will be, and it will be equal to tan P by 2 upon tan Q by 2 upon 1 minus tan P by 2 to tan of Q by 2. So we know about this because we have found out its relation just now with respect to coefficients. We also know about this. So simply let's try to find out the left hand side. And we also know that P by 2 plus Q by 2 is what? Let me go back. And P by 2 plus Q by 2 is what?
45 degree.
Yes. Okay. So now what will be tan 45?
1.
So this is 10, this is 45. So this will be 1. Now tan P by 2 plus Q by 2 was what? Minus of B by A. Tan, into 1 minus C by A. Right? The product of fruits. So now taking LCM in the denominator, A minus C by A will get cancelled. Minus B upon A minus C equals to 1. Taking the A minus 1 to LHS cross multiplication, A minus C is equals to minus of B. Now we have the relation between these coefficients. Now let's see the options. So what we've just found out, A minus C is equals to minus of B. A minus C is equals to minus of B. So, okay, everything is positive sign. So A, B, let's bring the B to the LHS and C to the left hand side. A plus B is equals to C. Option number B should be our answer. Correct? Is that clear?
Yes, sir.
Yes, what we have done is that we have understood that we know the sum and the product of fruits, and which should be giving us the formula of tangent, the combined angle of P by 2 plus Q by 2. So we also find out the angle. So we knew the LHS, we knew the RHS, and all the after solving all those terms, substituting, we will have all of our calculation will be in the variable, will be in the coefficient of the given quadratic equation, and hence we'll be able to find out the relation between them. And also it will not be clear to you in the starting because it's life. We don't know what is coming next. You just have to keep on trying whatever intuition, whatever mathematical intuition you will generate. It will take time. With practice you will be able to see and look at the question and tell it that how it will be solved, but it will build with time slowly. Okay, so you have to practice for that.
Yes.
Moving on to the next question. Yes, it was correct. Okay, so it is given that the product of roots of the equation is -1. So the given quadratic equation is here. And what is the product of roots? Alpha and beta is what?
C by A.
-1, it is given here, and C by A. Okay. So what is C here?
2m minus 1.
Yeah, what is C here in the quadratic equation is 2m minus 1. Upon A is what?
M.
Yes, cross multiplication. Minus m is equals to 2m minus 1. Bringing this on the left hand side, bringing this on the right hand side, this on to the left hand side. So 1 is equals to 2m plus m, 1 is equals to 3m, m is 1 by 3. So A should be our answer. Clear?
Yes, sir.
Yeah. Yes. Nature of roots. So we have discussed it earlier also. Now you tell me what is discriminant of this quadratic equation? No problem if you don't remember.
Minus b plus or minus root b square minus 4ac by 2a.
Okay, this is what? This is what? X. This is
X.
the Sridharacharya formula by which we have to find out the root of any quadratic equation. So this is root. This is not discriminant. Discriminant is
Okay.
this, whatever there is under the
Okay.
b square minus 4ac.
4ac.
Its sign and its nature will go on to define our nature of roots. And as like if the discriminant is positive, like it's greater than 0, then the roots are real and distinct. If the discriminant is equals to 0, then the roots of the equation are real still, but they will be coincident, means they will be same. And if it is negative, then the roots of the equation will be imaginary and they will be different, of course. And further on, if the roots, like if the discriminant was positive, and if it is a perfect square, then the roots will be rational. And if the positive discriminant is a non-perfect square, then the roots will be irrational. Clear?
Yes, sir.
Absorb this slide, read this once. Done?
Yes, sir.
Okay, so any doubts?
No, sir.
So now tell me what are irrational numbers?
Which are not in the form p by q?
Yes. Okay, so those numbers who cannot be written as in the form of p by q, where p and q are integers, and q must not be equals to 0. Okay, fine, great, very good. Let's now discuss this example. If the roots of the equation are real and distinct, then all possible values of a are. So it is a given quadratic equation where we do not have a constant. In constant, there is a place of a. So this quadratic equation can be perceived in two ways. We can look at it from the perspective that it is a function of a, and then considering the quadratic equation is in a and a is the variable, or we can consider that the function is in x and the quadratic equation is in x, and we'll find out the value of x, or is the equation will be defined. Okay, so there are two ways. Anyways can be perceived by us, but as it is given in the question, we will do so accordingly as per the question. So here, if the roots of the equation are real and distinct, then all the possible values of a. Now we have to find out the value of a. So it will be beneficial for us to consider the term of a as a coefficient or constant for the quadratic equation in x, so that we will be able to find out the nature of roots. Because now first tell me, when are the roots real and distinct? On discriminant being negative, being 0, or being positive. When are the roots real and distinct?
0, sir.
Yes, roots are real when discriminant is 0, but they are distinct too, like they are not same.
Okay.
The discriminant has to be positive, more than 0. Then the roots will be real and as well as distinct.
Okay. Yes, sir.
So what is discriminant is b square minus 4a. Here b is, what is b here?
8, sir.
Minus of 8. Minus 4 into a is 1 and c is what?
A square minus 6a.
Very good. So this is the discriminant and it should be greater than 0 as per the given condition. So now let's solve for the a. 64 bringing this into right hand side. 1 4. Correct? 1 6. So now a square minus 6a minus 16. This is another quadratic equation now. Let's find out its roots. So we require two numbers whose product is minus 16 and whose sum is minus of 6. No, sorry, whose sum is plus 6 because whenever we write quadratic equation in the form of roots, so we will do so by, so there is a negative sign here. There is a negative sign here, which is also here. So the sum of roots should be positive 6. Is that clear? Clear?
Yes, sir. Yes, sir.
Okay. So what can be those two numbers? If the product is 16, let's simply factorize 16, 2 into 8. Oh, we got it. So if we'll just take these two numbers, 2 and 8, so the difference is 6 and the multiple is 16. So we can just 8 minus 2 will work. 8 and minus 2 should be the roots. Okay. So we can write it further. And also if you are smart enough, then if you are like experienced enough, then you can directly write that the a should be in positive. So a minus 8 will be written, and if the root is in negative minus of 2, so it will be plus 2 here, a plus 2. Understood how so?
Yes, sir.
Let me rewrite it for you. A square minus of 8a plus 2a, then only minus 6a is going to come. Now we will take a common, a minus 8 plus 2, 2 common, a minus 8, then taking a minus 8 common into a plus 2 and the same inequality. Okay, that's how. So we already find out that the roots are 8 and minus 2. So the roots are only going to come when like 8 will be positive only when there is a negative sign. So that it will, when it will go to the other side, so it becomes positive. Okay, that's why the like sign is changed in this condition, in this equation, inequalities. Okay.
Yes, sir.
Yeah. Now let's learn about a method that is wavy curve method. That. Okay, so let's understand it here only. That wavy curve method is used to find out the like limit of any variable. So in wavy curve method, what happens is first for that we need to find out the factors. Like if there is any given function and it is given, it is with the, there is an inequality like less than 0 or something like that. So first let's understand what is this. Here a is less than b. and B is greater than A. Okay. And if we write so with this a bar, then it means A is less than B or equal to B. Understood?
Yes, sir.
Or we can vice versa, we can also say that B is greater than A or equal to A. So the equality conditions includes when we include the bar sign with the inequality sign. Okay. So VB curve method says that first of write the inequality and then you have to factorize it. Okay. So we have done the factorization. Now represent a number line. Given that the roots are real. Okay. So because if the roots are imaginary, so complex number cannot be compared. Like inequality in complex number is not defined. So the roots has to be real. You learn about it in the chapter also. So beta should be negative, minus of beta. Alpha is positive, so alpha will be here because it is tending towards plus infinity. This is going towards minus of infinity. Now, if the coefficient of the variable, like what are we finding out about x, right? So if we have to make sure that the coefficient of variable that is x here has to be positive. So if it is positive, is it positive here? Is the variable of x, sorry, coefficient of x is positive? Please answer.
One is positive, but what about alpha, sir?
No. Both are positives. What is
Okay.
coefficient? What do you understand by?
Yeah, sir. It's positive only.
Ah,
Means 1x, right? So yeah, positive.
1x here also. So if it is positive, then simply go to the rightmost part. Like there are three sections in this inequality. This is one section, this is second section, this is third section. So go to the rightmost section and the given this is the function, like let us call this as a function. So the function will be positive here for all values of x, greater than alpha, for all values of x greater than alpha, the function will be positive here. The function will be positive here for all values of x greater than alpha. Now understand one thing, that on alpha and beta, whenever the function is becoming zero, so when something becomes zero, like let's say, like it is mostly assumed that a function is like let us consider this is a function. So it is mostly assumed that whenever the function is being zero, when it is zero when its value is zero, this is f of x, this is x. Whenever the f of x is becoming zero, so whatever the sign of fx was earlier, here it was positive, then it will become negative. So after zero, here also the function is becoming zero on some value. Let us say this is a critical point, this is another critical point. Here also the function is becoming zero, f of x, y is zero. And then the sign earlier was negative, now it will become positive, f of x sign. Same goes for here, same goes for here, right? Understood?
Yes, sir.
Yes, it's an assumption. There can be an exception, like what if there is a curve who is becoming zero, but still it's positive earlier on also and later on also. So this is called as a point of inflection. Anyways, let's not go into that. But there's a good chance, there's good chances that this assumption will always stay true. So this will be positive, this will be negative, and again this will be positive cyclically. Okay.
Yes, sir.
So now what we had to find out, the function was negative. We had to find out the values of x for which the function is becoming negative. So here, when is the function becoming negative? In which section?
My
Hmm?
minus alpha.
Minus beta to alpha.
Sorry, minus. No.
Yes.
Yeah, sir. Minus beta to alpha.
In this period, the function is becoming negative. Now is the question, should we include minus beta or minus alpha or not? It will depend on whether the inequality includes the equality condition or not. If the inequality condition has included the equality sign also, then we have considered this as a node, and we will include the values of alpha and beta, and we'll write as that x belongs to minus of beta to alpha, and minus of beta and alpha is also included. But as here there is no such equality condition, so realistically we will write that x belongs to minus beta to alpha, but minus beta and minus beta and alpha is not included. There will be a hole here. All these values will be considered in between, and particularly minus beta and alpha will not be there. Okay.
Yes, sir.
I hope you know about closed interval and open interval. Do I need to explain?
Yes, sir. I know.
Okay, you know. Great. So closed means that beta and these two values are included. Open means these two values are not included. Okay. So let's
Not
now discuss about
included.
this. Yes.
Isn't that not included, sir? If it is open means.
No, they are not included when they are open.
Okay.
And if it is otherwise and you come to know later, then please tell me, I'll correct myself.
No, sir. Because I don't know. Like I forgot, so that's why I asked you again.
Yeah, it can also happen that I may also misunderstand. It's completely okay to correct me. 0 less than a minus 8 into a plus 2. This was the inequality. Yes, now we are better equipped to solve this. So as per our discussion, plus infinity to minus of infinity, this is a line of x. Okay, so 1 is 8, 8 will be written here, and minus 2 will be written here. Is that correct? Is that correct? Huh?
Yes.
Yes. Think.
No, 8 should come that side, minus 2 should come this side.
Why? Why?
Negative comes left side only, no, sir.
Yes, correct. And even 2 is also less than 2, less than 8. So now back to the discussion. These are our roots. Now, is the coefficient of variable positive or not?
Positive, sir.
Yeah. So the rightmost section f of x will be positive here. And let us say if there was a scenario that we had written 2 minus a instead of 2a plus 2, then what we have to do is simply we have to put any value of x, any value of a greater than 8, and check for the right hand side whether it is becoming positive or negative. Okay.
Yes, sir.
Understood? So what we are doing right now is we are making shortcut because one condition is satisfying for us. because the coefficient is positive here. Otherwise, also there is a method to solve. There's always some method to solve. Okay, so the f of x is positive for this particular interval. The interval is 8 from 8 to positive infinity, like it from 8 onwards. So here will be here the function will be negative, here it will be positive. Now checking the f of a should be less than 0. So what it means? What it means, which section we have to refer? This one, or this one?
Hmm. Is it this
The
second
function
one,
will be
sir?
negative. Second one. Second one.
Yes, sir.
Yeah. So a belonging to -2 and 8. So now what should we write? Open interval or closed interval? Should we include these two values or not?
We should include it, sir.
We should include it. Why? We are humble. That's why.
Uh,
There is no equality sign here. So we will not,
okay.
yeah. So we will not include
And
them. If there was any equality sign present, then only we are going to include them. See,
okay, okay.
yeah. See why it is so? Because simply we are finding like there is a function f of a, and it has to be less than 0. So it means that we had to find out values of a for which the function is negative. Okay, we have found it out so. But if we will include -2 and 8, the function will become what? What is f of -2? What is f of -2? What we
Y-
will get when we will put a as -2?
Which is 0.
Yes. So if this is becoming 0, which is not satisfying our inequality, so we should not include -2 and 8 as well, because 8 is also a root. Understood?
Yes, sir.
And if the condition was given like this, that whether it should be less than 0 or equal to 0, then we can include or not.
Then we can include, sir.
Yes, clear. Great. So this should be the answer. -2 to 8, and it should not be included. Yeah. B should be our correct answer. Clear?
Yes, sir.
Great. So where's the solution? Here's the solution. Clear?
Hmm.
Okay.
Yes.
Now let's discuss about the relation between sign of coefficient and the roots. So this is the given quadratic equation, and its roots are alpha and beta. So now we will discuss about the signs of A, B, and we will find out that whether so if A is positive, B is positive, C is positive. If you do you face like do you confuse oftentimes with the inequality sign whether it is saying less than or greater than? So let me tell you a trick if you do or not. So if, wherever the this consider this as Pokemon. So wherever the mouth is open, that will be a king, really bigger than the other one. So wherever the mouth is open towards, so that thing will be greater. Okay, clear? Clear?
Yes, sir.
Yeah. So when A is positive, B is positive, and C is positive, then the roots will be negative. Okay. And how we have found so? We have simply find out the alpha plus beta will be will be minus b by a. So if b minus b by a, and if b and a both are positive, so alpha plus beta should be negative, right? Think when b and a both are positive, and the division of both of them are getting multiplied by a negative sign here. So the overall will be negative, right? Clear?
Yes, sir.
Yeah. And alpha beta will be what? C by A. So C and A both are positive. So positive. So alpha, this is going to become positive. This is going to become negative here. So when two numbers are added, when they will become negative, it can be one scenario that one smaller number is subtracted from the greater number. Okay, so one can be positive, one another can be negative. And it can also be one case that both of the numbers are negative and they are summed. Okay, it's like -2 and -3. That will sums up to -5. That can be also one scenario. For clarification out of these two conditions, we'll have to refer to the product of roots. Now here the product of roots is positive. So the first scenario is wiped out. One root having been negative and another being positive, then the product will be negative. So it is not the scenario here as per our second conclusion. So now there's only one condition left, that both of the roots are negative, and when they are multiplying to each other, then their product itself is positive. That's how we have found out. So okay,
Yes.
understood?
Yes, sir.
Similarly, we have found out about all of the rest. When A is positive, B is positive, and C is negative, both roots are of opposite sign. Opposite sign means if one root is positive, the other root will be negative. If one root is negative, the other root will be positive. That's what. And it is a condition. It is a condition here that the positive root will be less than the negative root. And we are not considering the sign of negative here. We are just looking at the magnitude of roots. Okay, because that's why we have written the what is this modulus function. Yes, that's why we have applied modulus on both of the sides, and we have said that the negative root, whichever the negative root is going to be greater than the positive root in the scenario where C is negative. Understood?
Yes, sir.
Yeah. Another condition, when A is positive, B is negative, and C is positive, so the roots should be positive. Okay.
Yes, sir.
And when A is positive, B is negative, and C is negative, these two conditions are like somewhat paired and related. When A is positive, B is negative, C is negative, then the roots will be opposite in signs as per earlier. But the only difference is the positive root will be greater than the negative root. The magnitude will be greater. Okay.
Yes, sir.
Yeah. So now let's discuss about transformation of roots. Ax square plus bx plus c is the quadratic equation. A, B, C are coefficients having alpha and beta as their roots. So if it is given that there is a quadratic equation, let's say 2x square, no, I have to show. Now let's say what are its roots? I just made this quadratic equation by myself, so by summing 2 and 3 and multiplying 2 and 3 here. Okay, so now let's say if it is a given condition that you have quadratic equation this and you have these two roots. Now, if it is asked from you that you have to make a quadratic equation whose roots are negative, then its roots. So if 2 and 3 are the roots, so its negative roots will be -2 and -3. So we can directly find out the quadratic equation by just changing the sign of its. Okay. X square plus 5x plus 6 should be the equation. Now let's check. So when we will put -2 and -3 here, then what will happen? We will be able to satisfy this particular quadratic equation. So if we will try to find out its roots, there should be two numbers whose sum should be -5 and product should be plus of 6. So -2 and -3 are those two roots, okay, which are also the negative. So that's just one example where we are proving this that all these stay true. So if you have to find out a quadratic equation of roots 1 by 2 and 1 by 3, let's simply bring 6 here and -5x will remain here itself and 1 here. We have changed C and A from their places, interchange C and A. Understood? If we have to find out the quadratic equation in which the roots are squared like 4 and 9, so simply square the A square. A is 1 here, so x square plus 2ac, 2ac to 1 into minus of 5 minus b square. B square is 25. Then -10 minus 25, that is minus of 35. So it will become x square minus 35x plus c square. What is c here? So this is the now equation. Okay.
Yes, sir.
Am I doing any mistake here? Because its roots are not 4 and 9. It should be 13 here.
I'll check. I'll check.
What is the mistake?
So now I should find the root only, no, sir. That's what I'm checking. Why even I'm not getting it?
C is 6 here, not 5. That's the mistake. So plus 12
Oh,
and minus 25 will make it minus 13. So here it will be minus 13 of x. So this is the quadratic equation having roots, having square roots, whatever the roots were given to us originally. So I've just given you examples using this quadratic equation. You have to remember these three quadratic equation whenever we are like transforming the roots as of their negatives or reciprocating them or squaring them. Clear?
yes, sir.
Okay, let's move ahead then. Now, symmetric function, these are simply driven by identities that we can write alpha square plus beta square like this. We can write alpha minus beta square like this. So what's the concept behind it? The concept is that what do we know about a quadratic equation? So it's about like utilization of our current knowledge and using it wherever required. Okay, like modifying our current tools, and we have modified them in such a manner that we are able to use them in more scenarios. The domain, the usefulness of that particular tool has increased. So what we know about the roots of a quadratic equation is a sum and the product. So by using these two only, we are going to find out alpha square plus beta square, alpha square minus beta square, alpha plus beta, alpha cube plus beta cube, all these. How we will do so? We will use our identity knowledge that we know alpha plus beta square is alpha square plus beta square plus 2 of alpha beta. So now what we do not know here, we know this, yes. We do not know this, okay? We know this, yes, alpha, beta, we know this. So we will simply do is we'll write it as alpha plus beta whole square minus of 2 alpha beta. What is this? Minus b by a. What is this? C by a. So after solving this, we'll be able to find out these results which are written here. Clear? So alpha minus beta will be find out by squaring root of alpha minus beta whole square, and this will be find out by multiplying alpha plus beta into alpha minus beta. Alpha minus beta is we already know, and alpha plus beta is minus b by a. Alpha square plus beta square will find out. I have just told it earlier also, and here it is also written somewhere. Yeah, here. Okay. So, and this will be find out by using this alpha plus beta cube and minus of 3 alpha beta into alpha plus beta. And all these have found out simply by the identities which I have given you in the basic mathematics class. Basically using that, there's no different formula. This is nothing new. Okay.
Yes, sir.
Oh, is my voice audible?
Now one day I could hear your voice, sir.
Okay. So what we have done, we are like taking an example so that we can better understand. Even if in exam times it may happen that we forget them, then how we can derive them. Simply, we have converted them in a format of alpha plus beta and the product of these two. Then further on, after substituting the value, we have taken the LCM a square as here and b square minus a square upon a into 2c. That becomes 2ac. So this is the same. This also must be also written the same in the next page. Alpha, yes, b square minus 2ac upon a square. Okay, that's the same. And similarly, we can find out the others also. Do you want me to derive them all? Please tell.
So,
Should I? Please tell unhesitantly. No problem.
yeah, sir.
Okay. So let's start with. Please respond. Yes. Now it's working fine. So let's start with alpha plus beta. We already know. This is we know. Now let's start with find out the value of alpha minus beta. So let's first see its square. Now we know that a square minus b square is a plus b into a minus b. Okay. So if we do this, alpha minus beta whole square minus of alpha plus beta whole square will be equal to a plus b. If we like sum these two terms, alpha plus alpha, 2 alpha, beta minus beta will nullify, multiplied by a minus b. So alpha minus beta minus of alpha minus of beta, these are this, and minus of 2 beta here. So this is minus 4 alpha beta. Understood how have I written so?
Yes, sir.
Yeah. So we know about this alpha plus beta, we know. Okay. Minus b by a whole square. So b square by a square. This is we have to find out alpha minus beta whole square, because we are finding out alpha minus beta, so we will just simply square root it after solving it. So minus of 4 alpha beta is what? C by A. So taking this to the right hand side, b square upon a square minus 4c by a. I have already solved this. Now I remember. After taking no, I have not solved this, but this one that was different. So taking the square root on both sides, b square minus 4ac upon a square. So a square. So and the square root is on both of the terms. Now we can also remove the square root from the denominator by simply removing the square root upon this, because there was a square. So this should be our answer. Alpha minus beta should be square root of b square minus 4ac upon a. Let's check. Yes, it is the case. Now let's find out for the alpha square minus beta. Are you able to understand that how have I calculated? So
Yes, sir.
yes. Now let's try to find out about alpha square minus beta square. It is simply alpha plus beta into alpha minus beta. We have already find out its value as b square minus 2ac, if I'm right. No, I'm wrong. Why I'm wrong? Yes. B square minus 4ac upon a into minus of b by a. So it is minus b into b square minus 4ac upon a square. It should be the correct one. Yes, minus of b into b square minus 4ac upon a square. So are you like, is that clear?
Yes, sir.
Okay, now let's discuss about these two. I have already discussed about alpha square plus beta square. Is that clear? Is
Yes, sir.
that clear?
Yes,
Because
sir.
we have solved about this term, then we brought this to the left hand side, and that's how we have solved for this. Okay.
Yes, sir.
Now let's talk about this. So alpha cube plus beta cube. Alpha cube plus beta cube. So let's find out alpha plus beta whole cube, because that is giving us an intuition that we'll be able to find out alpha plus beta cube is there here also. So into 3 alpha beta into 3 plus beta. Now we know about alpha beta and also about this term. So only the alienated element is this. We also know about this. So the cube of minus b by a will be minus of b cube upon a cube. And this we have to find out. Plus 3 alpha beta is what? C by a. Alpha plus beta is what? Minus b by a. So bringing this to the left hand side, minus of, this is already minus, so it will become positive. 3bc upon a square minus b cube upon a cube is equals to a cube plus b cube, a beta, a cube, sorry, alpha cube plus beta cube. Now taking a cube common here as an LCM here, so here will be 3abc minus of b cube is equals to alpha cube plus beta cube. Now let's find out, and taking b common here, b square minus 3ac upon a cube should be the answer. B square minus 3ac upon a cube. I think we have missed one sign here. Yes, we have taken common, but here 3ac should be written first. Now we have done like in reversely. So for that we have to apply a negative sign here. Is that clear? Why we have to do so? Clear?
Sir.
So you now got it, like आपको पता लग गया. You now come to know that for solving them we need to like do long calculation. So instead of doing so again and again in exam, and this kind of questions is being repetitively asked by Andy, so why not remembering these? Okay, this is important. Clear?
Yes, sir.
Yeah. And don't try to like remember them. Just try read and understand why every step is happening. Okay, question everything, every statement, every step. Then you will be able to correlate things that these are simply manifestation of the algebraic identities which we have already discussed and which you already know. They are just like playing with them and writing them as per as per their convenience or as per our convenience, because we have to use them in this manner. Okay.
Yes, sir.
Yeah. So I guess that's all for today's class. Let's do this question also. So there's one more. This is left. This is left to be solved. Okay. So how it will be solved is, let's consider there is a quadratic polynomial. This is f of x. So its roots are alpha and beta. So what do it means that for f of alpha it will become 0, for f of beta it will become 0, right? So let's put alpha at the place of x. So let's divide alpha on both sides. Sorry. B plus C by alpha is equals to 0. So what we were finding out, so A alpha plus B becomes minus C by alpha. And for beta, it will be just the same. But just you have to replace the beta, and here also it look like this. So this is what we had to prove. A alpha plus beta is minus C by alpha, and A beta plus B is minus C of beta, minus C by beta. Is that clear? Yes, Rishi. Yes, Yarini. Clear, Rishi?
Sir, yes, sir.
You know Hindi?
Sir, little bit, sir.
Okay, good. Great. Yes, Yazini. Sorry, Yarini.
Yes, sir.
Okay. So let's solve this example. निपटा देते हैं. Yes. So in the given quadratic equation, we have to find out this. So beta upon A alpha plus B is what? Minus C by alpha plus alpha upon minus C by beta. So bringing this alpha to the numerator, alpha beta by C minus, and this will also A alpha upon C into alpha beta. This will be also in negative. So it will become like 2 alpha beta 2 into alpha beta by C. Alpha beta is what? C by A. C was already there. So it will become minus 2 by A. A should be our correct answer. Clear?
Yes, sir.
Yes.
Sir,
Now
sir.
see. Yes, Rishi?
Sir, sir.
Sorry?
Sir, nothing, sir, nothing.
Okay, sir. So this is the solution. Now see how in how many steps they have solved it. And we have remembered some terms, then only we are able to solve that fast. Okay. Any doubts from today's class?
No doubt, sir.
Great. So it's your homework. I'll send the PDF of today's class notes and please revise them and practice by yourself, because there will be no use of teaching me here and you're attending classes of here. If you do not go and use those mathematical tools and use your brain to solve these problems, because I'm not teaching you the answers of these problem or questions. I'm trying to teach you the method that how problems are solved. And if you practice the same method, then only you will be able to generate the same method, you will be able to learn the same method, and as well you will be able to create new methods. Okay, so please practice.
Sure, sir.
Great. Thank you. Good evening, Jai Hind.
Thank you,
Thank
sir.
you, sir.